Okay, for this last video, what I'm going to do is work through all of the problems on your assignment. So if you're following instructions and watching this video, then we're going to work through the entire assignment for section 11.2. And of course, if any of your classmates are just messing around and not paying attention, then they won't get the assignment done. Okay, so here we go. We're just going to work through every single problem. And if you have a problem done and you don't have a worry, feel free to jump ahead in the video so that you can just move on to the next one that you might have trouble with. Okay, so number 2, we're given the diameter of a circle is 16 feet and we're asking for the area. All right, so the idea is we need to remember the formula for the area of a circle. The formula for the area of a circle is pi r squared, where r is the radius. So we have to remember that if we're given a diameter is going to be equal to 2 radii. Okay, I'm assuming you probably will remember that. A diameter goes from circle to circle through the center, so therefore it's really just made up of 2 radii. Okay, so if the diameter is 16 feet, that makes the radius 8 feet. So since the diameter is 16, the radius would be 8. So we just simply have to replace r with 8 in our formula, and 8 times 8 is 64. So the exact area is going to be 64 pi square feet. And if anybody would prefer the decimal approximation, that's about 201.1. So 201.1 square feet. Okay, number 4, this time we're given the area of a circle and we're asked for the approximate radius. And whenever we're given the answer to something like a circumference or an area or later on this year a volume, we start with the formula for what we're given. So in this case, we're given the area of a circle, so we start with that formula. Area of a circle is pi times the radius squared. And what we're going to do is we're going to replace the area with what it's equal to. The area in this problem is equal to 380 square inches. So we replace A with 380. And then your job is to solve for R. Well, to get rid of times, we divide. So we're going to divide both sides by pi, because what that allows us to do is cancel the pi's top and bottom. So we'd have R squared is equal to 380 divided by pi. And then to get rid of the power of 2, we do the inverse. And the inverse of squaring is taking a square root. So the square root and the square cancel, leaving us with just r, which is what we're looking for. And then on the other side is the square root of 380 divided by pi. And if we use our calculators to approximate that, 380 divided by pi, and I take the square root of that, and I get almost just a hair under 11. So just let's be a rebel and just call it approximately 11 inches. My calculator actually gave me 10.998, so I'm just going to call it 11. Okay? Like anytime we have these videos, feel free to pause if you need to finish up one of the problems. Don't worry about that. Just feel free to pause. You should have plenty of time. All right, the next one's almost identical. We could probably skip this one. You guys are probably good enough at this, but I'll run through it anyway, since I said I was going to do every problem. Once again, we're given the area of a circle, but this time, instead of asking you for the radius, I'm asking you for the diameter. No big deal. What we'll do is we'll find the radius just as we did on number 4, and then we'll just remember that the diameter is equal to 2 radiuses, 2 radii. Okay, again, anytime we're given the answer to an area, circumference, anything like that, we start with the formula. The formula for the area of a circle is pi times the radius squared. And what we're going to do is we're going to replace area with 676 pi. Okay? And again, your job is to solve for first r, and then we'll remember that a diameter is 2 radiuses, 2 radii. Okay, so once again, to get rid of times pi, we divide by pi. But this time we kind of set it up, we rigged this so it works a little bit nicer, because on the left-hand side, we have a pi in the top and a pi in the bottom, so those also cancel each other out. And now to get rid of a power of 2, we just simply take the square root of both sides. And so r is going to be equal to the square root of 676, which I believe is 26. Yeah, Yep. So the radius is 26, and therefore a diameter is going to be 2 of those. So 2 times 26 is 52, and we're measuring in centimeters. Okay. Number 8, we move on to sectors, and yesterday I gave you a formula for sectors. Okay. And in the directions here, it asks us to find both the area of the blue and the area of the red. Okay. Sectors. Okay. And so we have to find both, and I'll just use colors here so you can tell the difference between. And since this is just the first one of these we've done, I'll just remind everybody that from yesterday I gave you the formula for the area of a sector as being the angle divided by 360 times pi times the radius squared. So that's our formula. All right, so as an example, to find the area of the blue, so area, A for area, and then I'm going to find the blue. What we do is we take the angle at the center, 256, divided by 360, and then multiply by pi, and multiply by the radius. You can see in the problem the radius is 14 squared. Okay, and that's all there is to it. We move to our calculator, and we take 256 divided by 360. We get kind of a crazy decimal. We multiply by pi, and we multiply by 14 squared. And what we should get as a result then for the blue area is approximately 437.9 square centimeters. Okay, and then the red sector area, so the area of the red, is going to be the angle divided by 360 times pi times the radius squared. The radius is still 14, but what changes when we move to the red is the angle. Right, the blue angle was 256. What's the red one going to be? Well, of course, the two together form a complete circle, so the two together add up to 360. So if the blue angle is 256, the red one is 104. So I can insert 104 for the angle, and once again, just move to your calculator and do the arithmetic. 104 divided by 360, again, kind of crazy decimal, multiplied by pi, and multiplied by 14 squared. And we should get approximately 177.9 square centimeters. Okay, so we're supposed to find the area of both blue and red. Okay, moving on to number 10, same directions, all right, exactly the same directions. And I'm just going to choose to do them in different order this time. I'm going to choose to find the area of the red first. And the reason I'm choosing to do that is because they give us the angle at the center for the red sectors. So that's going to be the easier one because, again, right off the bat, they give us that angle as 75 degrees. So it's 75 divided by 360 times pi times the radius. And this time the radius is 4, so times 4 squared. And once again, we just simply move to our calculator, 75 divided by 360, multiplied by pi, and multiplied by 4 squared. And we should get approximately, for the area of the red sector, we should get approximately 10.5 square feet. All right, and then I'll switch over to blue. And to find the area of the blue sector, we have to take the angle at the center divided by 360 times pi times the radius squared. The radius is still 4, same circle. But now the blue angle, a little hard to see on the picture, but I'm trying to indicate it in blue. We're not given that blue angle. But once again, we know that the two add up to 360. So if the red angle is 75, the blue angle is going to be 285. So the blue angle then 285 degrees. And once again, we can just move over to our calculators and approximate this area. So 285 divided by 360 times pi times 4 squared. And if I punched out, okay, I got 39 point, oh, no, something wrong there. There we go. 39.8 square feet. So there's the area of the red and the area of the blue sectors. Okay, again, feel free to pause the video anytime you need to, but I'm just going to continue to move along. Here's the picture for number 14, and a little bit tough to see on my iPad here, but the question is, what's the radius of the circle? So I'm just going to rewrite that off to the side so it's easier to see. So what I'm looking for is the radius of this circle. Okay, and what we're given in the problem is the area of the sector, 12.36. We're also given the angle, right? So how do we find the radius? Well, anytime we're given an answer, and let me choose a highlighter tool here. Anytime we're given an answer like circumference or area, we start with that formula. So the formula for the area of a sector is the angle divided by 360 times pi times the radius squared. So what they tell us in this problem is they tell us what the area is, 12.36. They tell us what the angle at the center is, 89 degrees. And the only thing they don't tell us is r. And again, let me highlight that. The only thing they don't tell us in the picture is r. But that's exactly what we're trying to find. We're trying to find the radius. So we solve for r. And like we are going to do in class some more, like we've done in other sections, I'm going to choose to do this in one step. And to get the r squared by itself, I'm going to multiply both sides by 360 over 89 and pi. The idea is, let me choose a highlighter tool so you guys can see it, so that the 360s cancel top and bottom, the 89s cancel top and bottom, and the pi's cancel top and bottom. So the 360s cancel top and bottom, the 89s cancel top and bottom, the pi's cancel top and bottom. So the only thing left over on the right-hand side is r squared. That's the only thing that didn't cancel. Now, whatever you do on one side, though, you have to do on the other. So I also have to multiply the other side by 360 over 89 and pi. And then we just simply have to do this arithmetic on our calculators, as I've shown you in class, and we're all done. So 360 times 12.36, and then divided by 89, and divided by a pi. And what we get is approximately 15.91. But we don't want the radius squared, we just want the radius, so we have to take the square root of both sides. And so the radius then is going to be the square root of 15.91, so approximately 3.99. So about 3.99. And if you guys wanted to round that up to 4, I'm totally fine with that, but I'll just write it out so you get the idea. So just about 3.99 meters. Okay? All right. Then the next two are going to be a little bit tougher. These are going to be some of the subtraction problems that you saw in the video. And the directions, as you can see for number 16, and then it'll be the same for 18, is find the area of the shaded region. And I asked you to do these as subtraction problems. So to calculate the area of the shaded region for number 16, what we have to do is start with the area of the square, because that's the big object. That's the largest object in the picture. And then what we have to do is subtract away 4 areas of circles. We have to remove the 4 circular areas. The 4 circular areas. I thought I said that wrong, but that's okay. All right, so we're going to do it as a subtraction problem. Okay, so area of the square, and then minus the area of the 4 circles. Okay, so individually, come on, this thing's jumping around on me. There we go. Okay, individually, the area of a square is just simply one of its sides raised to the second power. So one of the sides of the square is 20. So we're just simply going to have 20 squared. Then one of the areas of the circle is going to be pi times the radius squared. And then we're just going to have 4 of them, so we'll multiply by 4. So what's left really is just finding the radius of the circles. Okay, and you can tell by the tick marks that all 4 are the same size. So once we find one radius, all of them are going to be exactly the same. So the key is that all the way across the bottom, as an example, is 20 inches. So then if we looked at one of the diameters, That means that that diameter then would have to be 10, because if each of these diameters is 10, 10 plus 10 is 20. But if a diameter is 10, then that makes the radius of any one of those circles 5. Okay, so after that kind of logic, we'd know that the radius of the circles are 5. And now we're left with a relatively simple problem. 20 times 20 is 400. Pi times 5 squared is 78.5. So we're left with 400 minus 4 times 78.5. And what we're left with is 86. And we're measuring in inches. So the area of the shaded region is approximately 86 square inches. Okay, so again, you start with the area of the big, remove what you want to toss out, and what's left over then is the blue shaded region. Okay, all right, and number 18, same directions, so same idea. We're going to find the area of the shaded region by taking the area of the big circle and then removing the inside circle, so removing the small circle, and then also removing half of the, oops, sorry, I missed the half there, guys. Also removing half of the area of the ring. Right, so we start with the area of the big, we subtract away the area of the small inner circle, the inside part of the donut, but then we also have to remove half of the outside ring. Okay, so take a look at that, pause the video if you need to, want to kind of get a feel for that. And then also while you're looking at that, just notice that they show us the distance 8 centimeters from the inner circle to the outer circle, and then because of the tick marks, that means we also know the inner circle radius is 8. Okay, so therefore the area of the big circle is going to be pi times its radius squared. Well, if that inner part is 8 and the outer part is 8, the radius of the biggest circle then is 16. Okay, and then we're going to subtract away two things. We're going to subtract away the area of the small inner circle, and I'll color that in red. So we're going to get rid of this inner circle, which means that's going to be pi times its radius squared. And then we're also going to subtract away half of the outside portion, okay? And so what's going to be left over with half of that outside portion, let's see, how should I do that? I got to get rid of half of that. Right now we have all of that. I guess maybe I could do it like the following. So I'd have to take away half of what we've already done. So this would be half of pi times 16 squared minus pi times 8 squared. Yeah, that would be half. Yep, so that'll work out just fine. So 16 times 16 is 256 pies. 8 times 8 is 64. Oops, sorry, I missed the 4. 64 pies. And then we also have to subtract away half of the ring. So that's going to be, let's see, just need a calculator for that subtraction. And yep, and then I need half of that. So that would be 96. Oops, come on, pencil. That would be 96 pies. So 256 minus 64 minus 96 would get us 96 pies. And what are we in here? Centimeters, right? So that would be square centimeters. And if anyone prefers the decimal, that would be approximately 301.6 square centimeters. Okay. Number 27 asks us to find the area of the shaded region. And once again, just continuing with that idea of subtraction. So we start with the area of, in this case, the big circle. And, oh, I forgot to write down, hang on guys, I forgot to write down shaded. So area of the shaded region is going to be the area of the big circle minus 2 of the areas of the triangles. Okay, the triangles are the same shape, you can see by the tick marks. So we're going to need to take away 2 of those. Okay, alrighty. Now, for both of those, for both the area of the big circle, what we're going to need to know is the radius of the circle. And for the triangles, which of course the area of a triangle is 1/2 times base times height, we need to make sure that the base and the height are perpendicular to each other. So a little bit of geometry from the previous chapter. Since each of the triangles has as its longest side this diameter, the top triangle has that as its longest side, the bottom triangle has that as its longest side. All right, and therefore the red line I just sketched in is a diameter, and from our previous chapter that forces this angle to be 90 degrees and this angle to be 90 degrees. Both of those would have to be right angles. Therefore we have right triangles, and because of the tick marks, the single tick mark sides are 3, the double tick marks sides are 4, and therefore we can find the diameter length. I'm going to indicate it right here in a brighter color like purple. So we can find this long side by using Pythagorean theorem. So 3 squared plus 4 squared is going to be equal to the hypotenuse squared. Okay, and you might recognize the numbers and you know the answer is 5, but I'll show you the work just in case. 3 times 3 is 9, 4 times 4 is 16, 9 plus 16 is 25, and when we take the square root of both sides, we get h being the square root of 25, which is 5. So therefore the diameter of the circle is 5, and therefore the radius is 2.5. And because those are right triangles, we then know that the base of one of the triangles is 4 and the height is 3. And we're all set to go. So 2.5 times 2.5 is 6.25 pi. Then 2 times 1/2 times 4 times 3 is 12. And when we use our calculator to approximate, let's see, and then subtract a 12, I get, oh darn it, 19.6 minus 12. And I get approximately 7.6. And what are we measuring in here? Meters. So the area of the shaded region, approximately 7.6. Okay, and the final problem for this assignment is to find the measure of angle ADB, ADB, and this is going to be a two-parter. This is going to be a two-part problem. Okay. The first part is to get the arc from A to B going the short way, the short direction. And we have a theorem again from the previous chapter that the angle at the center is going to be equal to the arc. So since the angle at the center is 121 degrees, the arc is going to be 121 degrees. Which means then that you can find the length of the arc from A to B the long way. I'll try and outline that in green. Remembering that those two together form a complete circle, so they have to add up to 360 degrees. So if the red arc is 121 degrees, the green arc is then going to be 239 degrees. So there's part one. And then part two is to remember that when we have two tangents drawn to a circle, the angle formed is going to be half the difference of the two arcs. Half the difference of the two arcs. So the angle located at D is going to be equal to half the big arc minus, pardon me, the small arc. Okay, so 239 minus 121 is 118. And then half of 118, I believe, is 59. I'll double check that. Yep. So 59. So the angle at D is 59 degrees. Okay. Alrighty. So that takes care of the entire assignment for 11.2. Okay. So I'll see you guys on Monday. All right. Hope you have a nice weekend.